All right, here's for our second video, coming back now, going the opposite direction, changing from rectangular form to polar form, where, just a reminder, rectangular form is any equation that has only x and y as the independent and dependent variable. And then the polar form we want to convert from rectangular into polar, for now our independent variable being the radius and the dependent variable being theta. Okay, but as long as don't worry about the independent dependent part, just as long as you have r and theta, that's what you're looking for. So the question now is, with these four identities, which one is going to be useful for us to substitute in order to rewrite the equation in terms of r and theta? Looking at number 6 here, this is a continuation from the last video where we left off at number 5. So I see x squared and a y squared. In which of the top 4 has an x squared and a y squared? If you said number 1, you're absolutely correct. So I can rewrite this by adding y squared to both sides and say x squared plus y squared equals 25. Now we can see that right here, x squared plus y squared, well, that equals r squared. So r squared equals 25. Well, yes, we are done. We could also say r is going to equal 5 if you square root both sides. Now, you won't need to do a plus or minus here because what it's saying is that the radius is 5. It doesn't matter in the direction. So if you plotted every single angle possible with a radius of 5, whether it was negative 5 or positive 5, you'd cover all your bases and you'd have a circle with radius 5. Number 7, what does this become close to? I think it's close to number 2. We have x. Well, we know what x is equal to. We know x is equal to r cosine of theta. So we can write this as r cosine of theta is equal to 2. So direct substitution. This is officially done. However, if you wanted it so that one variable is on the left and then the other variable is on the right, kind of an input-output situation, then you could write it as r equals 2 divided by cosine of theta, which is also equivalent to 2, so that's 1 over cosine, and 1 over cosine is secant of theta. Either of these three choices would be fine with me. However, know that on answer keys you would see the most simplified form, meaning they don't leave it as a fraction. So that would be your best answer. And number 8, very similar to number 7, I see a y, and there is a direct substitution for y. Y ends up being our sine of theta equals minus 2. And then doing the same thing we did for simplification in number 7, we could say r is equal to minus 2 over sine of theta, which is minus 2 cosecant of theta. This will be the most simplified version. So once again, to make this transition, what we know is that 1 over sine of theta equals cosecant of theta. And in number 9, let's see what we have in store for us. All right. So what I see in number 9, if I can ever scroll down there we go, we got it. I see a y and an x. I don't see an x squared, I don't see a y squared, so I'm not looking for that number 1 where it's x squared plus y squared equals r squared. But I see a y and an x, and I know that I can directly substitute in for both of those. In the form of 2 times y would be r sine of theta, x would be r cosine of theta. plus 10. Now your equation only has r's and thetas. It's a matter of just cleaning things up now. It's officially done. This is all in polar form, but the answer will only be recognizable on answer keys when you're looking to simplify further and further. And typically the goal is to get r on one side and theta on the other. Just like in rectangular coordinates or Cartesian coordinates, same thing. When you have y on one side and x on the other. For example, y equals mx plus b. So what I can see here is that there's an r in both of these terms. So I get them on the same side of the equation by going 2r sine of theta minus 2r cosine of theta. And that's going to equal the 10 that will be left on the right hand side. You can divide everything by 2, reduce it further. So you get r sine of theta minus r cosine of theta equals 5. Then I also have a common factor of r. So I can factor out r to get sine of theta minus cosine of theta equals 5. And then you can get r by itself by dividing by the sine of theta minus cosine of theta to both sides. Now this factor will reduce, and you get r is equal to 5 over the sine of theta minus cosine of theta. Now in the previous question, we simplified further. We rewrote it because we could, and we didn't want to write it as a fraction just because it looks a little cleaner. In this case, because we have two terms that are subtracted, it's just going to complicate things if we go any further. So that will be your final answer, although the first step, it technically is in polar form. It's just we simplify further to get a more simplified answer. Now there's two more examples. Number 10, we're using the same strategy as we have the last couple, where yes, I see a y squared. Yes, I see, well, and not an x squared, but an x cubed. But this is x squared. No, it's not. But I see a y, I see an x. And I can rewrite that with direct substitution like the last two as r sine of theta squared equals r cosine of theta cubed, which is also the same thing as r squared sine squared of theta equals r squared cosine squared of theta. Oh, sorry, that's cubed. That's a cubed on the right hand side. So now to get r on one side, what we can do is we can divide both sides by an r squared. And we can see that these r squares would reduce. And on the right side, there's one more factor of r on the top, so that would just become r cosine cubed theta equals sine squared theta. And now to get r by itself, you can divide by cosine cubed of theta. Now know that like everything I'm doing right now is just simplifying. This equation is totally in polar form, but we are going to continue going further with this. So now cosine cubes will reduce and you'll get r equals. Now on the right hand side, I'm going to write this a little bit different. I'm going to write this as sine squared theta over cosine squared theta times cosine theta. Because if I multiply cosine squared times cosine, I would get back cosine cubed. But what I'm seeing is that sine squared plus cosine squared, well, sine over cosine is tangent. So sine squared over cosine squared would be tangent squared. And then if I look at the other portion right here, 1 over, and there's a an assumed 1 there because you can multiply anything by 1. 1 over cosine, that is secant. So for the yellow term here, I will have tangent squared theta. For the green term here, that would be, if this comes back into focus, secant of theta equals r. Okay, hopefully you can see that. Okay, all right, we got that. Now hopefully this video is working okay and you guys can see what I did. And that's the most simplified form, r on one side and then theta on the other. Now for the next one, this equation is going to be in the practice problems I gave you, so I made sure that this was part of the things that I'm going to be going over. Now as we look at this equation, x squared, y squared, they're not by themselves. X and y, yeah, they're not necessarily by themselves too. They're kind of trapped in these parentheses. Now, one thing, this is a mistake on my typing here, but I'm just going to fix it right now, is that this should not be a cube, this should be a squared, okay? Because that's the way it's going to be in your homework. So what we can do here is we can actually multiply this out, and you'll see that we'll have some opportunities for substitution afterwards. Where the first term here, we would get x squared plus 2x plus 1. I'm doing the multiplication out pretty quickly, but you can do this on the side a little bit slower at home. This will be x plus 1 times x plus 1. Okay, if you multiply that out, you will get exactly what I get here. And then doing the same thing for the y minus 3 squared, you're going to get y squared minus 6y plus 9 equals 10. All right, so I see that I'm going to have 1 and 9. That's going to make 10. But I'm also going to subtract that over to the other side, and that's going to give me 0. And I see that I have no other common terms. Okay, so I can, but I have something. I have an x squared and a y squared. What could I do with that? Yes, that's right. If you said we can substitute to make r squared, you're absolutely right. So we're going to have r squared coming from x squared plus y squared. And then what we have left is the 2x and the minus 6y. So I'm going to write that down, not do too many things at once, plus 2x minus 6y. This equation is so close to being in polar form. The only thing that's stopping us is that we have an x and a y. So now we can use that direct substitution for both my x and my y. And I can write this as r squared plus 2r cosine of theta minus 6r sine of theta equals 0. That is completely fine to write it like this. The equation is in terms of r and theta. However, on the answer keys, what you will see is that they will divide through by a common factor of r. It is not relevant to this. I would not recommend getting in the habit of doing this going forward, but because what it does is it gets rid of one solution. But that solution is not necessary for this polar graph. So you get r plus 2 cosine of theta minus 6 sine of theta equals 0. And then finally they would write it as r equals, subtracting both of these terms over. I'm going a little fast now because I'm going to run out of time. It'll be minus 2 cosine of theta plus 6 sine of theta. And that will be our final answer. I hope that helped. And this is our final video here for 319. All be well. Take care and let me know if you need help.